Hello everyone, welcome back. Today's video is on weathering, the process by which we are making sediment, breaking down rock and turning them into smaller bits of rock. The learning outcomes of today's video is to differentiate between physical and chemical weathering. We're going to identify the environments in which those occur, and then we'll discuss types of physical and chemical weathering. So like I mentioned, weathering is the process that begins the breakdown of rocks at the Earth's surface. Anything that you put into the environment tends to break down. The natural environment is super, super harsh. You may not think of it as being very harsh. When it's cold outside, you just throw a jacket on. Sometimes you wear shorts outside when it's a lot warmer. But this freeze thaw, the movement of the cycles, the cooling and heating that occurs even during the day is something that we as humans have yet to develop materials that can maintain for. Our oxidative environment, the oxygen in the environment is constantly degrading metals and rusting things. You have trees here that is lifting up sidewalks. So building things that stay in the environment is very, very difficult. And that's because the environment is such a harsh place to live, even if you don't view it as such, since we are able to basically climatize to it with different clothes and heating and things like that. But rocks don't have that luxury. And so when they're exposed to these harsh conditions, they break down. And so to get started, we have our physical weathering processes. That is when rocks are getting broken down into smaller and smaller pieces without altering the materials. So think of it as taking a hammer to a big boulder and breaking it into a lot smaller pieces. That's physical weathering. It's a physical process, me hammering this rock into smithereens. Here we have pressure expansion. Just like me sitting down on my chair right now, I am applying pressure to my seat and I'm expecting that seat to apply a pressure back. And when someone takes that chair out from under me, I will fall to the ground. And so rocks form chemical bonds deep under the ground with this expectation of pressure being applied to it. And so as erosion occurs and that pressure is taken away, these rocks crack because they're applying their chemical bonds are applying this pressure outward that isn't being reciprocated anymore. And so that'll cause them to fracture. Here we have a sort of granite batholith, and these are formed underground under intense pressure. And eventually, when those get exposed on the surface, like Half Dome and Yosemite, they'll start to fracture off into these sheets because of this lack of return of pressure. And that's called pressure expansion. We have a process called frost wedging, which is a physical weathering process. It entails water, which is a chemical, but the water is freezing, then expanding, which is cracking that rock open. An interesting property of water is that ice is less dense than water. So if you have water in a crack and it freezes, it has to expand because it's less dense. It needs to take up more volume than it did as a liquid, and that causes cracks, and it makes cracks more severe. And this is a process called frost wedging. Water has gotten into the crack, it's expanded and worsened the crack. Root wedging is a similar wedging process, but it's done by plant matter. That photo on the first slide of a tree growing through concrete, that is a process of root wedging, because slowly over time, these fibrous roots get into cracks. They grow larger and larger and larger until eventually the rock cracks and crumbles into different segments. That is called root wedging. We also have salt expansion, which is basically the delivery of ions via water into these cracks. This is common in saltwater environments. you have water entering the cracks. It's precipitating a solid, salt halite in this case, which is larger than it was before. It now has a structure, a bulk structure. We've delivered ions through water, and then it solidifies into a crystal, and that releases a pressure which cracks the rock as well. So that's called salt expansion. This is a big problem in Venice, Italy. I did a research or a study abroad there. And Venice, Italy has a big problem with salt expansion in their infrastructure. Most of the palazzos and buildings in Venice are made out of brick, and these bricks are porous. They allow salt water in, they allow seawater in, and when the seawater evaporates, that salt dries and cracks it off. This wasn't an issue before because the water in the Venice Lagoon was a lot lower, but now with global climate change and the sea level rise that we're seeing in our oceans, Venice is now experiencing more high water events, which means that there is water getting to higher places on these bricks. It's exposing the bricks to a lot of seawater. It's washing away and then solidifying into salt, fracturing the brick, and eventually degrading the structural integrity of all of these buildings, all of these heritage buildings in this case. So that's a big problem and one that does not really have an easy solution, unfortunately. There are also aeolian processes, which is aeolian is Latin for air. And this is basically a polishing of rocks or a weathering of rocks by just blowing, sandblasting rock at it in a desert environment. So I like to watch videos of sort of sandblasting on cars or things like that. When you restore stuff, you'll throw grit at it to remove rust or paint material to it. This is sort of a natural sandblasting that's occurring on the rock. Now moving on to chemical weathering. This is happening on surfaces where chemical weathering happens on surfaces because reactants can't penetrate rock surfaces. This is a chemical transformation instead of a physical transformation. Instead of taking the larger rock and turning it into a smaller rock, this is transforming that rock into something that maybe has less structural stability and eventually wears away. Minerals are dissolved or changed into other minerals, and this is dependent on the amount of surface area that is exposed. A big factor of this is rain. Whenever rain falls, it's weakly acidic, and that's due to its presence in the atmosphere. It gets a lot of dissolved CO2 in it, which makes it weakly acidic. Here's this carbonate system showing up again. CO2 is turning into carbonic acid, which then dissolves maybe the calcite that was maintained on that rock and weakens that from a solid into an ion and breaks it apart. So that is facilitated by rain, and then that rain can cause dissolution where a calcium carbonate or another carbonate ion is dissolved into an ion. So it's no longer a solid. We're moving from a solid to an ion. That's a process of dissolution. And this is how you form big karst caves. Stalactites and stalagmites are a reprecipitation of this dissolved calcium carbonate. When you see these really beautiful cliffs at Mammoth Hot Springs in Yellowstone, that is precipitated calcium carbonate, but it was made from mobilized ions that can precipitate in new chemical formations. So it is this exchange, this constant solidification and dissolution of materials. Another chemical weathering process is oxidation, the biggest one being rust. Rust is a very expensive oxidation process where we're turning a metallic metal into an ion again. Here we have a solid metal olivine complex which then gets dissolved back into an ion, whether it's dissolved iron or dissolved carbonate. Rust is estimated to cause $2.5 trillion of damage each year. That's about 3.4% of the global GDP. So basically all money on Earth, 3% of that is being burned every year to fix things caused by rust. Our infrastructure rusts constantly, cars rust, all sorts of vehicles rust. The tools we use out in the field rust. And so this is a really, really big issue that we don't really have a good solution for. And I think that's pretty cool. Our final chemical weathering process is hydrolysis, which is the process in which we turn things to clay. It splits water and then adds a hydroxide ion to a material, turning it into a new mineral. Here we've moved from a plagioclase, which is a silicate mineral, to another type of silicate mineral, but it's now a clay that we would classify as a clay. So that's pretty cool. And so we can plot these different types of weathering and relate them to different environments that we would find on Earth. One thing to think of is what caused all of the chemical weathering processes that we encountered. It's water. So as the environment gets more wet, we're going to see more chemical weathering processes. So strong chemical weathering occurs in tropical, wet to monsoon environments. So keep that in mind. One of the big physical weathering processes we saw was caused by ice. And so where are places that have ice? Well, it's where the average temperature is a lot lower, and a place where we can see a freeze thaw occurring, where water is able to get in the summer, and then it freezes in the winter, and then water gets down even further next summer, and then it freezes and cracks in the next winter. So a place that experiences a freeze thaw is a place where we'll see a lot of physical weathering. So that's also interesting to keep in mind. A place where we'll see very slight weathering of any kind is going to be the desert or Mediterranean environment, which is what we have here in California, which I think is pretty interesting. We don't get a lot of rain, and we relatively have a very high average temperature. And so that sort of omits any ice wedging that you would find. And so maybe a big weathering event that I could think of is probably just root wedging. There might be some slight chemical weathering, or I guess salt expansion if we're closer to the coast. So look at this figure and really try and digest what it's telling you, because we can take an environment and try and hypothesize what kind of weathering we would expect in that environment, which is eventually going to produce more or less sediment given on where we are. So that concludes my video today. Feel free to reach out if you have any questions. Thank you.